Hi, I'm Alexander, and today I'm going to show you how to factor a polynomial by using the rational zero theorem to find zeros. So here we have our equation. G of x is equal to x cubed plus 5x squared over 3 plus x over 12 minus 1 quarter, and we're being asked to fully factor it. Now, the rational zero theorem only works when all of our coefficients are integers. So first, we must factor out 1 over 12 from our polynomial, since 12 is the least common denominator. And so all of our coefficients inside the brackets get multiplied by 12. The polynomial inside still has the same zeros as g of x since we've only scaled it. Now, the rational zero theorem states that for any polynomial which has only integer coefficients, all its linear factors in the form ax minus b, where a and b are integers, must have b as a factor of the constant term and a as a factor of the leading coefficient. And if ax minus b is a factor, then because b over a is a 0, g of b over a must also be 0. This greatly limits the locations where a rational zero can possibly be. To find a zero of g of x, we just have to test combinations of b over a by plugging values into g of x and checking the function values to 0. B can be any of the factors of our constant term, negative 3, so that could be positive over negative 1 or positive and negative 3. Remember to include the negative of each factor. For example, negative 3 could be the product of negative 1 and 3. If instead, our constant term were a positive 3, it could be the product of two negative numbers, negative 1 and negative 3. A can be any of the factors of our leading coefficient 12, so it could be positive or negative 1 plus minus 2 plus minus 3 plus minus 4 plus minus 6 or plus or minus 12. So, when we list all possible pairs b over a, we get plus minus 1 plus minus 3 plus minus 1 half plus minus 3 over 2 plus minus 1 over 3 plus minus 1 over 4 plus minus 3 over 4 plus minus 1 over 6 and plus minus 1 over 12. Now we can test whether each a over b is a 0 by plugging them into g of x and checking if the result is 0. If you have a calculator, it might let you enter variable expressions, then evaluate them at a given value. Look in your calculator manual, ask a teacher, or look online. I'm going to do it going down my list. After plugging in some values, I see that g of negative 1 half is 0, so negative 1 half is a 0. Therefore, 2x plus 1 must be a factor of g of x. Now, we can factor out 2x plus 1 by using synthetic division on our polynomial. I list the coefficients of the polynomial on the right and put a 0, negative 1 half on the left. So we're dividing by x plus 1 half. And I'll do the synthetic division like so. And we end up with the coefficients of our quotient of degree 2 and a remainder of 0. But since I'm dividing by x plus 1 half instead of 2x plus 1, I must further divide our quotient by 2 since 2x plus 1 is twice x plus 1 half. And so we're left with 6x squared plus 7x minus 3 when we factor out 2x plus 1 from g of x. Great, so I've taken out one of the factors. Now we're left with a quadratic polynomial which we can easily factor using either the cross multiplication method as shown here, or the quadratic formula into 2x plus 3 times 3x plus 1. Had we been left with a higher degree polynomial, we would have had to continue using the rational zero theorem to find more zeros. So here we go. We've completely factored g of x into 1 over 12 times 2x plus 1 times 2x plus 3 times 3x minus 1, which is only linear factors, so we're done. Using this method is the most reliable way for factoring large polynomials, so remember it well. Thank you for watching.